So now we have a sequence of presentations just looking at the process of manipulating materials and building with CobBauge on site. And first up, we have Becky Little, who's a cob builder, who's going to talk to us about the sourcing and preparation of materials and some of the practical tests that we can do. I think you saw some lab tests there, but we've tried to produce a series of practical, simple, inexpensive tests to control materials quality, which are documented in the online videos, some of which Becky is going to share with you now. Becky, are you with us?
I'm here. Can you see me?
Yes, that looks fantastic. I shall hand over to you now.
Here I'm going to show you a few simple field tests to try and work out what kind of soil we have and if it's suitable for CobBauge. Once it's dug from the ground, especially in a drier season, in summer it might look like this, quite dry, and I'm looking to see different particle sizes. So I've got obvious stones here. Some are quite big like this. I can also see a lot more smaller bits of grit and gravel. But one thing I want to check is, do they break apart like this one? And that may indicate the presence of clay within the soil. The other thing I might do at this stage is smell the sample. If I'm concerned about having topsoil in it, then I'll probably smell the organic sort of musty odour of the soil. And it's best to avoid that and possibly dig deeper to try and find cleaner subsoil. And then we take that same soil and we mix some water into it to make it more plastic and sticky. And immediately I am quite clear that this has got a fair bit of clay in it. Just because it's very sticky, I can shape it, make a ball with it. And then when I press it in my fingers like this into a flat shape, there's just one big crack here. Maybe a little cracking there, but if this was very silty or sandy, I'm likely to get much more cracking once I press it in that way. Another thing that some people like to try is if you can make a ring around your finger, like so. Again, if there's lots of clay present, then you're more likely to be able to do that with the soil, is to make a long sticky ring. The other thing to say about soil in its damp state is if it's clay rich, it's actually much harder to get off your hands. So a hand wash test can be quite interesting because a silty subsoil can feel very sticky, but silty soils are actually much easier to wash off your hands and even off your buckets. So the stronger the clay and the stronger the bonds in the clay, the more difficult it is to actually wash it from yourself and your equipment. So that was the first of some of the training films that will be available online. Just to say, as a builder, I'm very much used to using my sensors when I decide if a soil is going to be workable in a building or not. And so we wanted to do the real sort of empirical, pragmatic, on-site field tests that are where you start when you arrive. And a lot of earth builders in this session will know exactly what I'm talking about. They'll have their own tests, I'm sure. They may use these ones. No test is definitive. It's just to help you begin getting intimate with your local materials. And this kind of place-based experience and knowledge is at the heart of the start of any earth building process. And you have to be able to do it this way because materials change over several meters across a field down into the depth of the soil, depending on the weather, depending on all kinds of real life things happening on building sites. So it's brilliant to have the science and laboratories, but it's also brilliant to use your hands, your eyes, your ears, your nose, sometimes even taste. Here's a test which is looking again at clay content. So I have my plastic soil. Again, it's the stony one, so I'm going to take out any large stones at this point, just because they will affect the way the test is done. So anything really big, take it out. The rest I'm going to make into a long, what the French call a cigar. I might call a sausage, but it's basically a very long cylinder. And I'm going to take a bit of time over this. So here we have a pretty long cylinder shape, roughly between 3 and 4 centimeters wide, and actually I kind of want to go as long as possible here, so if I had more space I would make something as long as I possibly can, up to about 1 meter long. So the next thing I'm going to do is I've got my long cylinder of subsoil, that I've a sticky cylinder, and I'm going to pass it over the edge of this table. Just check the diameter is between 3 and 4. Yeah, that's almost 4 centimeters. And then I'm going to just slowly pass it over the edge of something where it can drop to the, there we go. So it breaks there. So I'm going to collect that one here, and then I keep going. Each time just going really slowly and then watching where it breaks. Yep, there we go again. There's another break happened. So yeah, we'll just keep going, slowly pushing it along and seeing where it breaks. Trick is not to go too fast, just to give it a chance to find its weak point. There's one. There we go. We may get one more from this, we'll see. Yeah. So cylinders that break beyond 20 centimeters are often very clay rich and may well be suitable for a corrected or gauged cob mix, but also may be suitable for the light earth element of the CobBauge wall. But they may also contain a lot of silt, so that's where you may want to back up your field tests with some laboratory tests, which we'll look at later. If the cylinders are breaking at less than 10 centimeters, it's probably not got enough clay in it for any of the elements in a CobBauge wall, but it may well be suitable for other types of earth construction, and it may well be suitable as a soil you can blend with a richer clay rather than using washed processed sand. Okay, so I'm just going to keep chugging through the videos, but just that's a really good point to just stop at and say, remember, if you want to gauge a rich clay mix for the cob element, you don't have to use washed processed materials. It's perfectly possible to find a subsoil, a sandy subsoil, that will do the job for you. And this is something we really should be moving towards in all parts of earth building, is blending subsoils rather than using quarried processed materials. Another test you can try with the damp plastic soil is to make it into a small disc. We sometimes call this the biscuit test, or in France a galette. It's a little piece of plastic pipe, approximately 10 millimeters wide, and I'm going to use it as a mold. So I press the clay soil, or the sticky soil, still not sure how much clay is in here, into the end of the pipe, like so, and flatten it off. Check it's nice and full. You'll need to remove any larger stones to actually do this. So it's just the finer part of the mix, and then we leave this to dry. So here's some samples that we made before using the pipe, different kinds of subsoil. Already I'm going to have an indication of shrinkage with this test. I can't measure it very easily, but I can see from the way it shrinks back from the pipe how much it's shrinking roughly. But more importantly, at this point, I'm going to try and break these little dry discs, and they'll give me a sense of clay content and the type of clay and how strong it is. So I actually can't break this sample. I've got very familiar with doing these tests, and I know that this particular clay is quite strong. Yes, just about broke it. So I know there's a lot of clay, of strong clay in this sample. This one, the red sample we just made, and a little easier to break, but still pretty strong. Some people also like to try scratching these and using tools to see if they can break them down. Just to give you an indication of a weak one, this one I know doesn't have much clay in it at all, and it's pretty easy to break. So I'm probably going to be avoiding this soil to do any further tests. But the other ones that are clay rich are worth further investigation. Okay, so you can see there that we're, the more tests we do, the more we can find down into some potential good soils for building. That test, I've seen it done many different ways. Some people have larger bits of pipe, some people have little square blocks. I mean, it's obviously, if we can all start doing the same test, it's going to be a lot easier to interpret between us. But you do sort of get your own way of doing this, and then it's about comparing the soils within your local area. We'll just keep going to the last one. So the last one is the next step after the disc test, which is shrinkage. These are two samples of clay-rich soil, something that we'll look at when we're making mixers. It's also very useful for testing for clay content in both a soil and a mix, is using what's called a shrinkage box. In this case, it's 50 centimeters long by, actually these ones are 25 millimeters wide, but that's not so critical. It's as long as you can work out the percentage of shrinkage from the length of the box. These are quite a handy size to carry around. So we want the damp, sticky soil that we push into the box, make it flat, let it dry, and then measure the length dry. There are often a few cracks that happen as it shrinks. That's okay. And the other thing to say is take out your larger stones before you do this test. In terms of shrinkage, at this point, this clay had 8.2% shrinkage. This one was 5.2%. Both of these clay soils would need correcting or gauging in some way to make a cob that was manageable on site. But that's the next stage in the process. Hello, can you hear me now? Yeah, so I'm going to just let the next one run. So this little one, this is the same test again. You have a long wooden box, and this time I'm using the actual cob mix that I'm going to squash into the box. Ideally using the mix in the consistency you would to build with it. Again, it's a bit like modeling clay, although actually on site that can vary to some degree. But if we're trying to stick with a CobBauge kind of way of doing it, you're aiming for something plastic like this into the box. And so now I've gauged the mix. Possibly I've mixed a sticky soil with a sandy soil, and I've also put some fiber in. I'm using short chopped fiber instead of long straw, because a long straw mix is very difficult to get into the box. And then again, we're measuring the material once it's dry to get an idea of shrinkage. So that's kind of it for my little run of videos. These will all be available. You can go and look at them later. And yeah, just to say, I'm really pleased that we've had this collaboration between scientists and builders in this project, because often as a builder, it can feel a bit like the science is not doing the stuff that you need on the building site. And I just feel like that's been one very positive aspect about CobBauge in general, that the two groups of people are collaborating and giving each other information that makes both the building site more easy to control and have good quality, but also that it's quite realistic as well. And yeah, I think that's probably me. And yeah, final thing that again, just to go back to this thing about using your sensors. I mean, I'm it's kind of the thing that I go on about a lot, but it's so important for us, partly just to be able to respond to materials, but also it's really good for our healths in general and our well-being to just react with the world in a more sensory way. So just drop that one in at the end.
So that was fantastic, Becky. Thank you very much. And as she says, those videos are available on the website. And now, by the magic of the internet, we are going to be transported to London. Roland in London is going to talk to us about formwork and indeed the ECFE units, possibly.
Good morning and good afternoon to you, wherever you happen to be. One of the novelties of CobBauge is that we're using very traditional materials or slightly less traditional materials, so cob or mud wall or mass earth or bauge, very traditional building material, and light earth, which is slightly newer, maybe only 50 years old as a technique. But what the novelty of CobBauge is that we're putting these two things together in a formwork. And for a lot of cob builders, bauge builders, they've always worked by hand and by eye. But one of the things that we were thinking about with this is that we're trying to bring this to a new audience of workers who might have those carpentry skills already, but not the skills to build cob. So the thing about formwork is that if you put a normal formwork, like a concrete formwork, onto cob, then the only way that it's going to change is if you take the formwork away, because it can't dry inside a box. And so the first film that I'd like to show you is just talking about use of mesh in a formwork.
Cette vidéo montre l'intérêt d'utiliser des banches grillagées pour la technique CobBauge.
Pour le procédé CobBauge, on utilise des coffrages qui nous évitent de retailler la terre, la bauge, comme dans la technique traditionnelle. Donc pour ça, on a travaillé et mis au point des coffrages, repris des systèmes de coffrage béton, mais dont on a enlevé la peau de contreplaqué filmé et on l'a remplacé par du grillage. L'avantage du grillage, c'est que ça offre une surface de contact moins importante avec la terre, donc on a plus de facilité pour décoffrer. Et en même temps, les mailles offrent une surface d'échange avec l'air suffisamment importante pour permettre à la bauge ou à la terre allégée de sécher au travers. Donc ça nous permet de laisser les branches en place pendant 2 semaines, 2-3 semaines, le temps que la bauge et la terre allégée se raffermissent suffisamment, ce qui nous permet ensuite de remonter une deuxième branchée par-dessus sans aucun souci.
Enfin, le grillage permet de mieux contrôler la mise en œuvre de la bauge et de la terre allégée.
These films are either in French or in English with French or English subtitles. So this is about the use of the formwork after we've looked at the mesh.
Cette vidéo aborde les fixations des banches, leur stabilité, ainsi que leur manipulation. Ces banches en aluminium grillagées de 3 mètres peuvent être manipulées à 2 personnes facilement. Il existe aussi des banches de 1,50 m manipulables par une personne pour les détails ou les fins de mur. Ces banches sont attachées entre elles à l'aide de serrages pour assurer la continuité de leur aplomb et de leur niveau. On peut aussi utiliser des étais afin de garantir l'aplomb sur de grandes hauteurs. Certaines pièces d'angle spéciales peuvent faciliter le montage des banches et leur réglage. Les banches en parallèle peuvent être attachées de 2 manières. La première consiste à aligner les trous placés dans le cadre et à y passer des tiges de coffrage à serrer. Si, lors de la manœuvre, les trous du cadre ne peuvent être alignés, le grillage permet de laisser passer les tiges. Les tasseaux de bois vont alors permettre d'appuyer les tiges sur le cadre et non sur le grillage trop souple. Solidarisées entre elles, les banches peuvent être manipulées d'un seul bloc afin, par exemple, de simplifier les déplacements pour la levée suivante. Dans le cas où vous faites le choix de réutiliser les banches entre chaque levée, nous recommandons de les retirer 3 jours à 1 semaine après la mise en œuvre, mais cela dépend de la teneur en eau du mélange lors de la mise en œuvre. Retirer trop tôt amène le risque de déformer le mur, Mais attendre plus longtemps rendra la terre trop dure et les finitions trop difficiles. Une fois la bauge mise en œuvre, nous recommandons de gratter l'excédent à travers le grillage à l'aide d'une truelle ou d'un racloir. En effet, en séchant, cette couche de bauge va emprisonner le grillage et rendre le démontage du coffrage plus difficile.
Okay, so one of the things that you need to know is that that is a system of formwork, but there are many systems of formwork. The site that I was standing on yesterday, you'll see this afternoon, the formwork's all handmade in timber, as it was in Plymouth. Formwork could be a simple box that you fill and move as in the traditional rammed earth method, or it could be the entire site, the entire build, fully formed. There's lots of different ways of using formwork, putting formwork together. The main thing with CobBauge is that because you're using wetter mixes, you need to allow it to dry so that it can stiffen, harden before you take the formwork away. And so that's why the mesh is so useful. It also means that formwork is a lot lighter than kind of concrete formwork or heavy timber formwork. And as you've seen with that French examples where they've used aluminium, or in the case of the English versions with timber, they're also much lighter than traditional formworks, so they're quite user-friendly in that sense.
We'll maybe come back to the ECVET units this afternoon, if that's okay.
Okay.
And we will now magically fly from London back to Normandy, where Francois will tell us about the actual building process of CobBauge. There we are.
Très bien.
Okay, so I'm going to give you a brief overview and show you some videos around the preparation of the various mixes. So I'll mainly focus on the cob mix and preparation of the cob mix. I'll show you some of these videos without sound, and I will give you a live commentary, but you can also watch these videos at your leisure later on. So where is the link? There we go. And I'm going to share my screen. So yeah, you've got a video that shows you different ways and the different tools that can be used for the preparation of the mixes, so different machinery that is available on site. So you've got loading machines, digger buckets, so they can be quite useful in the preparation of these cob mixes. I will let you have a look in more detail later on. So when it comes to the light earth mixes, which might not be as well known, one second, let me see, where did I put it? Apologies. So yeah, where's the video I wanted to show you? So, I wanted to touch upon this issue of the preparation of the light earth mix. So we've got two different videos that show you the different phases for the preparation of the clay slip, which is quite important for the light earth material. Here we have different ways to prepare this mix, so either using local soil, and this means we need quite a lot of preparation beforehand. You need to mix earth, like soil, water, and then you need some sieving. And this can be quite trying and tiring and complicated to do on site with some very clay-rich soils. So if we move forward and skip ahead, in this second part of the video, you see that we prepared using ready-made soil that was pre-dried, crushed, and sifted. And so this means that here the mixing on site is much easier and saves us some time and means we're not as tired. It means we can also control. I saw some questions about this, but it means we can control the quality of the slip and the soil content when we're making these different mixes and the dosing. So yes, the preparation of the light earth mix is relatively easy. We saw the barren mixer that Plymouth showed us live earlier on today. I mentioned in the chat that you can also use other cement mixers, more traditional mixers, that allow you to prepare these mixes. So I'm now going to show you another bit of the laying work. And here I'm going to tell you about the use of an intermediary formwork, so a placement tool. Let's see if the video works. I will share my screen again.
So in this film, we will look at how we use the formwork and the separator to create the composite CobBauge wall. So the wall is made up of 300 millimeters of a dense structural cob and 300 millimeters of a lightweight thermal cob. Here you can see that the separator has been inserted between the formwork, and the gap left is being filled with the dense structural mix. The mix is placed in up to the height of the change of angle in the separator. This gives you the depth of your first layer, which will be probably around 250 millimeters. The separator has an angle on it as well, which creates a zigzag effect and aids the join between the two materials. At this point here, the first layer of the structural mix is nearly complete. They are just tamping down the surface and then adding a little more material to make sure the whole area is full. At this point, the separator can be removed. It is designed so you can give it a wiggle to help separate it and then pull it out. So you can see now that there is a space left which you can then fill with the lightweight thermal mix in order to complete the composite wall. Once the thermal mix has been added, the whole process starts all over again.
La faible longueur de ces coffrages intermédiaires permettent de les glisser entre les barres de fixation du coffrage principal. On peut les déplacer au fur et à mesure de l'avancement du remplissage de la bauge. Il faut prendre garde de ne pas compacter la bauge au-delà de l'angle formé par les deux plans du coffrage intermédiaire. Cela rend compliqué le soulèvement et le déplacement de ce coffrage.
So there you go. That shows you the general implementation and use of these two different mixes. It's an easy laying or implementation in lab. and you can start understanding how things work on site. So it's not as attentive to a perfect smoothness as during the lab phases. So I'm just going to show you another video now that shows you the loading of a cob mix and then the phase where you add light earth. And I should share my screen again.
This video shows the first stages of placing the structural mix between the formwork on the first lift of a CobBauge composite wall. The formwork has been placed on top of the dwarf wall, and the first layer of structural CobBauge mix is going into place. In this case, it's being tamped down by foot, which is a traditional and perfectly effective way of consolidating the mix. Extra quantities of the structural cob have been placed on a platform adjacent to the formwork, making it easier to reach from the person who's forming the structural layer using the separator tool.
Pass me that bigger pitchfork, please. Yeah.
Once the structural layer has been compressed to the satisfaction of all concerned, and as this is the structural layer, it needs to be well tamped down into place, then the formwork separator can be removed. This creates the void into which the thermal layer is placed, and the first section of thermal mix, which is of a yellower colour, has already been placed at the beginning of this stretch of CobBauge wall. For future lifts, it'll probably be easier to complete all the structural layer first before adding the thermal mix. So the separator has been placed in the next section of formwork. It is being trued to remain upright, and then more of the structural mix can be put into place. In this particular building, there is a curved section of wall. Curved formwork has already been made, and narrower separator tools are used to help create the curve. The use of formwork does not mean you can't make more interesting forms for your buildings.
La bauge peut également être mise en œuvre directement dans les coffrages en utilisant les engins de chantier qui ont pu servir à préparer le mélange, ici par exemple le godet de la pelle mécanique. Le chargement à l'aide des godets télescopiques peut être un peu plus délicat dans la mesure où on contrôle plus difficilement la quantité de matière prélevée par le godet et mis en œuvre dans le banche. Grâce à l'utilisation des coffrages grillagés, il est tout à fait possible d'exercer un contrôle visuel du compactage en cours. On peut déceler les zones de creux, les zones de faiblesse, qui permettront à l'ouvrier de revenir, repiétiner, recompacter la bauge à cet endroit-là.
So there you go, you've got different implementation processes that are directly linked to the configuration of the site. We saw that there's some examples from the Plymouth pilot, and it's in an urban site, it's quite dense, there are quite a few difficulties to move around the project, so we need to and it's difficult to mobilize certain site machines, so you can load the cob or the light earth into the formwork by hand, by pitchfork. In Normandy, we were able to use machinery much easier, so both for the preparation of mixes and for loading the mix into the formwork. So we used the digger bucket, for example, and we filled the formwork with materials. So this meant it was easier during the building process. The work of the laying light earth is relatively simple. You've got a light material which you can also add in by hand, and it's light tamping required. So I'm now going to give the floor back to Tom. I think that I've covered most of the main implementation processes that I wanted to cover.
Merci bien, François. And I think that was great. There's been some interesting questions come through on the chat. Before we have a question and answer session, we're going to have a couple of presentations about the drying sequence and finishes. We'll hand straight over to our colleagues at Plymouth again.
One of the most important factors we found when building the Plymouth prototype was the need to allow sufficient time for the CobBauge material to dry. We encountered two stages where drying became important and critical to the program of the build. These were when seeking to remove sections of formwork, and secondly, when seeking to render and plaster the cob surfaces. For the first point, we specifically designed the formwork to permit 2 lifts consecutively. The first lift of formwork would be filled with the CobBauge material. This formwork would then be left in place whilst the second lift of formwork was placed on top of the first. Following placement of the second lift of formwork and filling it with CobBauge, we asked the contractor to pause cob laying for a week. This was because we found that for our cob material, a 3-week period between finishing the CobBauge and removing the formwork was required to allow the cob to dry sufficiently. If I was to do this project again, I would have included for 3 lifts of formwork. This would be on the basis that each lift takes about a week to complete. This is because there were some periods of downtime for the contractor, which really led to inefficiencies in the construction program. The second stage, where drying became significant for this project, was the time between finishing the CobBauge walling and finishing the render and plaster on the walls. As our cob work was completed just before winter, we had to stop work over the winter period to allow for the walls to dry sufficiently. It took approximately 6 months from completion of the CobBauge walling to rendering and plastering the building. Had the building been given the summer to dry out, I imagine this period might have been reduced. Drying times are a significant factor that needs to be accounted for from the start of the project, and something that all architects and designers should factor in as part of the programming.
Okay, so the aspect of the project I'm going to talk to you about now are the different finishes that we've used on the CobBauge building. This was an experiment that was set up before the building was built, where we took a variety of different lime and earth-based materials, put them onto test panels. So behind each of these finishes is a section of the CobBauge thermal mix. And then we mounted them in this frame, and this is in Plymouth and it's facing towards the southwest, so this is going to get all the weather that Plymouth has to offer. And these panels have been up here now for just over 2 years, so they have seen quite a lot of weather. And the reason why we did this is to assess the permeability and the permanence of different finishes. Because one of the essential things for any finish on the exterior or interior of a CobBauge building is that it has to be hygroscopic. It has to be able to let water vapour travel through it. This is commonly known as a breathing construction, which is a bit of a misnomer, but effectively what it is that any water that is trapped or created within the building or in the walls themselves is able to escape out through the final finish of the wall, because any moisture trapped inside would obviously have a very detrimental effect on the CobBauge walls. So we have here 6 panels with a variety of different finishes, And then right at the end, panel number 7 is actually just the CobBauge thermal mix on its own. And that has also been sitting there for 2 years. And although you can see that it's starting to come apart in places because the rain is constantly washing the clay off the finish, in fact, it has stood up remarkably well, given that it's just a mixture of clay slip and hemp shiv. But anyway, next to that, we have a proprietary finish. This is, I'm looking at my notes here just to check. This is made by Lime Green. So it's a bagged product. It's got a base coat and then a finish coat on top. And this one, I should have come to last, because actually this is the one that we've chosen to use on the CobBauge building because it has kept its appearance, apart from where a bird has decorated it. It's kept its appearance very well. We've actually cut squares out of it to test for its adhesion to the thermal mix, and that worked very well. And the sensor that is behind this panel is telling us that it is fully hygroscopic, but it's also keeping the material behind it dry. So if I come back a bit, I'll go through the other materials that we used. This is a hydraulic lime harl. It's called a harl because that is the method of applying it. Harling, most of you will know, is if you take a material like lime and you actually throw it onto the wall from a distance of, say, 6 feet. So that has been harled onto the wall. That gives it a rough finish. And the rough finish actually is very effective because that actually sheds water more quickly than a completely smooth finish. It's sort of counterintuitive, but it works very well. And this, again, it worked, all of them worked, in fact, to keep the material behind them dry, but to a greater or lesser extent. The next one along here, this is actually just an earth render with a coating of lime paint on it. And one of the issues with this one, as you can see, that the weather has had an effect and moisture build up along the bottom has started delaminating the paint, so it's coming off. So although we like the idea of the minimal amount of relatively high embodied paint finishes on this, it didn't perform well enough for the building. This is also an earth render with more of a lime on top. Again, I'm referring to my notes here. This has got a quicklime kibble, so a bit more surface on it, and apart from where you can see a couple of places here, it has withstood the weather better than one with just a painted lime finish. Coming back here, we have a finish which is similar to the lime green proprietary finish we use. This is another proprietary finish made by Best of Lime. It's a bagged finish. There are 2 coats, a lime coat and a warm coat, so I think it's an insulated finish. And this has performed well, but the surface just doesn't look quite as nice as the lime green. They're both self-coloured or through-coloured, so you don't need to paint them, but we preferred the look of the lime green, so that's why this one was discounted. And then finally, one of the finishes which actually performed best in terms of its hydrothermal performance was this. This is another harled finish, and this is actually hot lime harled. So Becky might put me right on this, but my understanding of a quicklime or hot lime is that the quicklime is mixed with water, and then as it starts its reaction is actually placed on the substrate where it's still producing an exothermic reaction, which of course makes it hot, which is why it's called hot lime. And I know this technique is being more widely used now. Traditionally, it was used for mortars and things like that. So that was another interesting finish. But the bottom line was that we went for the smooth finish of the lime green product, and also the lime green being a proprietary product, it had the requisite certification and guarantees. So how did we find out how well these finishes worked in terms of protecting the substrate, their hydrothermal performance? Well, what we did is
embedded in the thermal mix behind each of these surfaces is a little piece of wood, a wood block sensor. And the wood block will mimic the environmental conditions of wherever it's placed. So it'll tell us indirectly what the moisture content of the thermal mix is behind the render. And in order to get a reading, we've got a pair of wires coming off that wood block sensor, and we can use here a standard wood moisture meter, which has just turned itself off, so I'm turning it back on again. And we attach the pins to the two wires, and that's telling us that the moisture content behind the finish here on the earth finish is 17.9 or 18%. It's in that area, which is fine. That's a low enough moisture content that it's not going to cause any problems to the substrate. But if we compare that to the finish that we chose, the lime green finish here, and we have the same test, we can see that that one is settling at about, it's going down 12.5, 13%. So there is a slightly more protection here from the lime green finish. So the material behind it is slightly drier. It'd be interesting to see what the one without any finish at all shows us. And this might be a surprising figure. It's turned itself off again. So that is in fact better than the earth lime. That's roughly about 14%. And the reason for that is that it's a sunny day. So as quickly as this gets wet, it dries out again. So if you get constant rainfall, this will get completely sodden, which obviously isn't very good, but then it dries out more quickly. Whereas this, because of the protection of the lime green render on it, will always stay relatively dry. And that's why that is the finish chosen for our building. And I think if you're thinking of building with CobBauge, you can look at other lime-based finishes. Maybe the hot lime hull is an interesting one, but this is the one that we chose for our building.
Thank you, Jim and Matt from Plymouth.